This is week 12, number 1. It says ABCD is a parallelogram. If the measure of angle CDA is 66, then measure of angle BCD equals blank. The diagram is not to scale, of course. If we know that we have a parallelogram, then we have all of our properties that come into play. Opposite sides are parallel. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. The diagonals bisect each other, and so forth and so on. So if we're looking at angle CDA, we're looking at this angle right in here. It is 66 degrees. And we want to know the measure of angle BCD. Now, the one property that I did not state is the fact that consecutive angles are supplementary. Because essentially, since we have parallel lines here and here, the two angles that we're looking at, 66 degrees and X, would be same side interior angles. So they are supplementary. So 66 plus X would equal 180 degrees. And we simply solve for X by subtracting 66 from both sides. Therefore, X is equal to 114. Number 2, LMNO is a parallelogram. So just like number 1, how if we're told we have a parallelogram, all of our properties come into play. If NM is X plus 15, so NM, X plus 15, and OL is 3X plus 5, find the value of X and then find the measure of NM and OL. Well, since it's a parallelogram, opposite sides of a parallelogram are congruent. Therefore, we would set these two measures equal to each other and solve for X. So 2X is equal to 10, X equals 5. But not only did it ask for us to solve for X, it also asked for us to solve for NM and OL. So we must plug in X back in. And that's not a negative X, I'm sorry. That should be tick marks. So if we just plug in, I have 5 plus 15, they equal 20. And just to check, 3 times 5 plus 5 equals 20. So if we plug in and these two are not the same, then we've done something wrong if from the beginning we were stating that they were supposed to be the same. Let's look at number 3. Number 3 says, for the parallelogram, if the measure of angle 2 equals 5x minus 28, so this angle here, 5x minus 28, and the measure of angle 4 equals 3x minus 10, find the measure of angle 3. First of all, we need to know what x is. Because if I know x, I can then get a numerical value for either angle 2 or 4. And if I knew the measure of angle 2 or 4, it would be supplementary to angle 3 because they're consecutive angles. So I'm going to set them equal to each other. 5x minus 28 equals 3x minus 10. 2x equals 18. X equals 9. Now if I plug that back in, I can find the value of either angle 2 or angle 4. So let's see here, 3 times 9 minus 10, 27 minus 10 gives me 17. So the measure of angle 2 and the measure of angle 4 are both 17 degrees. So I need to now find the measure of angle 3. And since 3 is supplementary to both 2 and 4, we will say the measure of angle 3 plus 17 degrees equals 180 degrees. Solving for the measure of angle 3, so 163. We didn't just want to know x, it didn't want to know angle 2 or 3. It wanted to know the value for angle 3. Number 4, it says find the values of the variables in the parallelogram. The diagram is not to scale. Real quickly, we should see right now, with this being 102, then z equals 102. Now, by us having parallel lines, cut by a transversal, going through our properties of parallel lines, then we know that alternate interior angles are congruent. So x equals 29 degrees. So now we need to figure out angle y. A couple of ways to do that. One is the simple fact that we have a triangle right here, and the sum of the three angles of a triangle have to equal 180 degrees. Or, also, if we're looking at it in terms of a parallelogram, if this angle is 102, and we know this angle here is 29, these three angles, x plus y plus 102, should also equal 180 because they're supplementary, because they're consecutive angles. Either way works. And we essentially get the same thing because it's the same three angles of that triangle. So now we know that x is equal to 29, so if we substitute in, combining like terms, y equals 131, y plus 131 equals 180. So y is equal to 49. Z 102, x 29, y is 49. All right, number 5 and number 6. Now just number 5 right now. In parallelogram DEFG, DH is equal to x plus 3. HF equals 3y. So DH is x plus 3. Oh, yes. So DH is x plus 3. HF is 3y. GH is 4x minus 5. And HE is 2y plus 3. We need to be able to solve for both x and y. The diagram is not to scale. Now, another property about our parallelograms, or a property we've already discussed, is the fact that the diagonals bisect each other. So that means that D to H is congruent to H to F. So x plus 3 equals 3y. Also, GH from here to here would equal HE. So then I know that 4x minus 5 equals 2y plus 3. Now, a lot of you look at that and just throw your hands up because you have two equations with two unknowns. There's two ways, or actually three ways we can solve this. One of the two most efficient ways would be either by substitution or elimination. Either way works. If you're going to use elimination, you need to get x and y on the same side for both equations. If you're going to substitute, solve one of the equations for one of your variables. If I'm solving this, I would probably substitute, and I would move this one across to where x equals 3y minus 3. And once I have that, I will now substitute for x in this equation right here. I am now calling x 3y minus 3. And then bring down the rest of the equation. And now I only have one equation with one variable. Solve the multi-step equation. Combine your like terms. If I move the 17 over, I have 20. If I move the 2y over, I have 10y. So y is equal to 2. Now, if I know that y is equal to 2, I can take it and plug it in right here for that y. So 3 times 2 minus 3. 6 minus 3 gives us 3. So x equals 3 and y equals 2 in this particular equation or problem. And just a real quick way to check that, notice I should have x plus 3, which would give me 6, and 3 times 2, which would give me 6. So that lets me know those two are equal. And if I plugged it in on the same side, or the other two parts, it would be equal as well. Number 6. Find the values of x and y for which A, B, C, D must be a parallelogram. The diagram is not to scale. So now we're reversing roles. We don't know that's a parallelogram, but we treat it just like it is. If we're trying to prove something is a parallelogram, treat it just like it is. And in order for this to be a parallelogram, the diagonals must bisect each other. So therefore, 4x minus 2 must equal x plus 28. And 4y minus 7 must equal y plus 14. In order for this to be a parallelogram, the diagonals must bisect each other. Therefore, that is what we know. This x goes across, we have 3x. This goes across, we have 30. So x equals 10. And moving the y over, 3y, this one goes over, 21, so y equals 7. X must equal 10, and y must equal 7 in order for this to be a parallelogram. And that's our startup for this week.